Hello guys, once again I welcome here all of you in our marathon series of Gate 2022 examination. This marathon series is more is gate specific, especially for Gate 2022 examination. So today we gonna discuss our new subject, which is highway engineering, and today our topic is one of the chapter of highway engineering, which is geometric design. So today we're gonna discuss geometric design. Geometric design. As you guys already know, this in this marathon series, in these marathon series, we only discuss about some short things, some short formulas, some numeric things in this marathon series. So in geometric design, we're gonna discuss all the formulas, all the numeric things which came under geometric design. Okay. So look, geometric design, every year geometric design cover 2 to 3 marks in gate examination. Okay, and a lot of most of the question is from numeric portion. There is rarely asked from a theoretical portion. Otherwise, a lot of questions from numeric portion in geometric design. So first thing first, in geometric design, camber or cross slope. Camber or cross slope. Okay, in camber or cross slopes, basically there is a specific table which will help you to solve a numericals. Which table? Look there, surface type, and here camber. Sorry, yeah, camber. Surface type, camber. If you have a surface type, high type bituminous surface or a cement concrete, then you have a camber 1.7 to 2%. Like if you have a surface of, if you have bituminous surface or cement concrete surface, then you will get a camber of 1.7 to 2%, and of slope 1 in 60 to 1 in 50. Okay, so our next surface type is, if you have a thin bituminous surface. If you have thin bituminous surface, then you'll get a camber of 2 to 5%, and of slope is 1 in 50 to 1 in 40. 1 in 50 to 1 in 40. And moving forward, if we have a surface of water bound macadam surface, WBM surface, water bound macadam surface, then you'll get a camber of 2.5 to 3%. 2.5 to 3%, and a slope of 1 in 42 to 1 in 33. This is one. Okay, 1 in 33. And at last, if you have surface of earth, if you have earth surface, then you'll get camber of 3 to 4%. 3 to 4. Sorry. Then you'll get camber of, wait a second, then you'll get camber of 3 to 4%, and slope of 1 in 33 to 1 in 33 to 1 in 25. Okay, so do remember this table. This gonna help you in to solve numericals of geometric design. there will be one numerical from this portion. Basically this slope is important to solve numericals. Do remember this table. Okay, so moving forward, our next topic is side distance. What is side distance? Okay, side distance. Basically we have three type of side distance in our undergraduate level, which is in syllabus of our undergraduate level, which is a stopping side distance, overtaking side distance, and intermediate side distance. So first we go through with the stopping side distance. Stopping side distance generally we denote as ssd. Okay, in stopping side distance, so we have a basic formula. ssd is equal to lag distance plus braking distance. So we denote lag distance by d. Lag distance denoted by d. Its formula is vt, where v is in meter per second. What if v is in kilometer per hour? If v is in kilometer per hour, then d is equal to 0.278 vt. This is in, okay, and this will in meter. This is in meter. Okay, and here v is in kilometer per hour. Kilometer per hour. Okay, and our next is what is braking distance? Braking distance. We denote it from L, and basically braking distance L is equal to, we have a formula, v square upon 2gf. 2gf, where v is in meter per second, v is in meter per second, and f is coefficient of friction. Coefficient of friction. Okay, there is a there's a lot of chances that you'll get a single question from these topic from side distance. Okay, so combinedly if we write stopping side distance, oh, then ssd is equal to lag distance vt plus v square upon 2gf. V square upon 2gf. If you in question, if there is a efficiency given, if there is efficiency, then this formula is modified something like this. Then ssd is equal to vt plus v square upon 2gf, and this efficiency sign. Okay, and guys, one more thing, in ssd irc recommend, in ssd irc recommends t is equal to 2.5 second, and f coefficient of friction is equal to 0.35. Okay, this is recommended by irc for ssd. Okay, let's move forward to osd, which is overtaking side distance. Okay, then we'll move on intermediate side distance. For right now we move to overtaking side distance. Before going to overtaking side distance, we have want to do tables which will help you to solving numericals from ssd. There's one to two tables from ssd. So first table is, let's say there is design speed, it is in kilometer per hour, and there is a safe SSD. It is in meter. Okay, so if you have design speed of 20, 25, 30, 40, 60, 65, 80, and 100, then you'll get safe SSD is 20, 25, 30, 45, and 60, 80, 90, and 120 and 180, 120 and 180. Basically, yeah. So 20, 25, and for 30, 30, for 40, 45, for basically there is also 50. For 50, this is 60. For 60 is 80. For 65, 90. For 80, it is 120, and for 100, it's 180. Do remember this table. This will help you to taking assumptions in when you go to solve numericals. This will help you to taking assumptions there. Okay, if you like assumption, if there is a numerical where you where there where in numericals we have, if you get in numerical design speed of 80, and so you easily get safe SSD of 120. Okay, it's a kind of assumption. It is, these tables will help you in taking assumptions in numericals, which will make the question easy for you if you remember these tables. Okay, so our next table is in between speed to coefficient of friction. We have speed here, kilometer per hour, to coefficient of friction, coefficient of friction. Okay, it is denoted by F. So if you have speed 20 to 30, if you have a speed 40, if you have a speed 50, if you have a speed 60, if you have speed 65, if you have speed 80, if you have speed 100, and what you'll get coefficient of friction. If you have a speed 20 to 30, you'll get coefficient of friction 0.40. If you have a speed of 40 kilometer per hour, you'll get a coefficient friction is 0.38, and for 50 you will get a coefficient of friction 0.37. For 60 you'll get 0.36. For 65 you'll get 0.36. For 80 you'll get 0.35, and you'll get 100 also again get 0.35. Okay, so do remember this table. This will help you to solve numericals of gate examinations. We go through previous year questions. There are a lot of questions from these topics where you need to take assumption from this table. Like if you have in any questions, if you have a speed of 80 kilometer per hour, then you easily take by taking assumptions, you will easily take coefficient of friction of 0.35. Okay, so these two tables of SSD, and one more thing in SSD, gradients, effect of gradients in SSD. Okay, effect of gradients in stopping side distance, effect of gradients. Oh, I'm sorry. Yeah, what it is, effect of gradients. Okay, so first in effect of gradient, first is ascending gradients. Okay, ascending gradients, gradients. Ascending gradients is something like this. You have surface like this, yeah, and your vehicle is moving upward here like this. You know, your vehicle is moving upward. Then there is a, if you will draw FBD of this, then you'll get something like this. Here you'll get W cos theta. basically it is theta, w cos theta, w sin theta, and here we'll get f. Okay, this is ascending gradient. If you have this ascending gradient, you'll get a lag distance, I'm sorry, you'll get a braking distance is equal to v square upon 2g f plus n by 100, where n is ascending gradient, ascending gradient. Okay, and next point, if you have descending gradient, descending gradient, descending gradient means there is a surface something like this, inclined of with an angle of theta, and your vehicle moving downward. So if you will draw this with a speed of with a speed of v, with a speed of v, if you'll draw the fbd of this, you'll w cos theta or w sin theta and his f. Okay, so and here we will get braking distance of v square upon 2g f minus n by 100, where n is descending gradient here. Okay, so ultimately you'll get ssd of due to effect of gradients, you'll get ssd, modified ssd is equal to vt plus v square upon plus minus, basically plus for ascending gradient and minus for descending gradient. Okay, not here plus minus, no really, there it is, 2g f, if you have efficiency in questions, f if efficiency plus minus n by 100. Okay, do remember this formula and you'll easily get stopping side distance due to effect of gradients. Okay, this is it of our stopping side distance. Now we'll move on our next topic, which is overtaking side distance. What? Oh, overtaking side distance, OSD, denoted as OSD. Okay, for the sake of this, let's draw a diagram in OSD. Wait, consider this is our road. Okay, a two-way road, something like this. This is your road, and there is a lot of vehicles here. One vehicle, another one, and these vehicles moving this side, and there is a one vehicle here, there is a one vehicle here, and on a opposite side there is a also two vehicle, there will be also two vehicle, one is here and other will be here. Okay, and if this vehicle wants to overtake this one, if this vehicle wants to overtake this vehicle and need to come here, like so, overtaking side distances, so by what time this vehicle need to come to this position so that this vehicle do not collide with this one. Okay, so this is something all about overtaking side distance. If we denote by some numeric things, this distance is, let's say, d1, and this distance is spacing distance, which is s, denoted as s, and this distance is denoted as, let's say, d2, and this distance is denoted as d3. Okay, let's see one. This is a1, a2, this is b1, sorry, this is b2, and this is a3. Okay, this is something, let's say b, sorry, yeah. Okay, this is spacing s. Okay, this is all about overtaking side distance. Let's we move on over numeric things of overtaking side distance. So overtaking side distance is equal to d1 plus d2 plus d3. So what is d1? D1 is equal to vb into t plus d2 is equal to vb into capital T plus d3 is equal to 2s plus vt. Okay, where capital T is overtaking operation time, which is whereas t is equal to 4s on a, where a is in meter per second square. Okay, meter square per second, meter per second square, whatever you want to take. And t is if a is in kilometer per hour per second, if a is in kilometer per hour per second, then t is equal to 14.4 s upon a. Here a is in kilometer per hour per second. Okay, yeah. So if we also have here s is 0.7 vb plus length of vehicle. Basically length of vehicle is about 6 meter. So length of vehicle, generally it is 6 meter the vehicle. vb in also obviously meter per second. And if a vv is in kilometer per hour, then it is, this formula is modified into vb plus length of vehicle, where vv is in kilometer per hour. Okay, so this is all about this is our main formula of shit. This is our main formula of OSD, overtaking side distance. Guys, once again I'll tell you, if you need a deep concept of these topics, you'll go through with your books or whichever material you prefer. Here we only discuss the formulas of for the gate examination 2022. If you don't have knowledge of these chapters before, if you don't studied it before, then there's no point of watching this video. You'll never understand any of the things. Okay, and you'll never solve any of the question by seeing this video. So if you completed your whole chapter, then for the revision purpose this video will help you, otherwise it will not. Okay, so let's move forward. Let's one more thing. If what if we don't have value of vv, if there is not a, there's not given in value of vv in numericals, then what we'll do, there is a one formula for vv there. So if if vv value is not given, if vv value is not given, then we'll calculate vv is equal to v minus 4.5 meter per second, or, or vv is equal to v minus 16 kilometer per hour. Okay, so I think this is it, overtaking side distance. Let's move further to table, some tables of overtaking side distance which will help you in to solving numericals. So Here speed, which is in kilometer per hour, and here is safe overtaking side distance, safe OSD. So if you have a speed of 40, 50, 60, 65, 80, and 100, then you'll get overtaking safe overtaking side distance of 165, 165, 165, and for 50 you'll get 235, for 60 you'll get 300, for 65 you'll get 340, and for 80 you'll get 470, and last you for 100 kilometer per hour you'll get safe overtaking side distance of 640. So do remember these tables for the sake of ease in numericals. Okay, yeah. And here effect, if we talk about effect of gradient in overtaking side distance, so effect of gradient is is compensated by reducing the speed of overtaken vehicles. So here in overtaking side distance, effect of gradient is compensated by reducing speed of overtaken vehicle. So okay, and one more basic thing in overtaking distance. So desirable length of overtaking zone, desirable length of overtaking zone is equal to 5 5 into OSD, and length of shit, minimum length of overtaking zone is equal to 3 into OSD. These two things is very important in your numericals. Like if in numericals there will be asked that what is desirable length of overtaking zone, or what is minimum length of overtaking zone. So easily you multiply it by OSD multiplied by 3, you'll get minimum length of overtaking zone, and OSD multiplied by 5, you'll get desirable length of overtaking zone. Okay, so this is it of overtaking side distance. Let's move forward to our next side distance, which is intermediate side distance. In intermediate side distance, there is not a lot of importance for the gate point of view, but there is a single table. So we'll see to it. Yeah, so intermediate side distance, which is ISD. Okay, so here speed in which is in kilometer per hour, and here we have intermediate side distance, which is ISD. Okay, so if you have a speed of 20, speed of 20, speed of 25, speed of 30, 35, 40, speed of 50, speed of 60, 65, 80, and 100, then you'll get intermediate side distance of 40, 50. For 30 kilometer per hour you'll get speed you'll get intermediate side distance of 60. For 35 you'll get 80. For 40 you'll get 90. For 50 you'll get 120. For 60 you'll get 160, and for 65 you'll get 180, and for 80 you'll get 240, and for 100 ultimately you'll get 360. Okay, once again do remember this table for your numerical portion. Okay, so yeah, One more thing in intermediate side distance, that the measurement of intermediate side distance is made assuming both the height of the eye level of driver and the eye level of the object to be 1.2 meter above the road surface. What that if you if you want to measure intermediate side distance, you need to assume that both the height of the eye level of driver and eye level of object to be 1.2 meter above the road surface, above the road surface. Assume that ki eye level of driver and the object, of driver and the object is 1.2 meter above the road surface. So yeah, this is it of intermediate side distance. Let's move further in design of horizontal alignment. And basically, so not right now, we'll do it on in our next part second of geometric design. We will in part second we'll see a design of horizontal alignment and many more. Till now, this is it for part one of geometric design, and very soon we'll meet for our PYQ session after completing part second. Obviously, we'll meet on our next session, next to next session, on PYQs of geometric design for the GATE examination of 2022. Till then, do a lot of more practice for your GATE 2022 examination. Best of luck for your GATE 2022 examination, or whichever examination which will give you or anything. So till then, take care. Bye bye. Good day. Have a nice day. Thank you so much for watching this video. Thank you.